My dear students, welcome back to the class of computer graphics and visualization. Our today's topic is a very important topic, that is hidden surface removal. Okay, the name itself indicates the hidden surface, means the surfaces which are not visible in any image, that should be get removed, and how it is to be done. So, that is our today's topic. Okay. And this particular topic, hidden surface removal, is concerned, it is also known as visible surface determination. Okay. So, even both are same here, do not get confused. Either you can call it as a hidden surface removal, or you may also call it as a visible surface detection. Okay. The portion of the object or surfaces which are visible for viewing, okay, so that should be get detected. Is it clear? So, in both the titles we can make use of these titles over here. Okay. See, normally what happens whenever I am going to see any image, see for example, say just have a look at over this image is concerned here. See for example, say in this particular image, if you see, okay, so there are in a room there are so many cubes are available with different color cubes are available, blue, okay, orange, then yellow color cubes are available. And do you think that whether all these objects are visible, all portion of these objects are visible? No. Why? Because one object is overlapping with the other object. So, the object which is front side, that is visible, and the object which is back is not visible there. So, it means that some portion of some of the object is hidden. Okay. Normally, in most of the time in our 3D object space it happens there, even in our for our natural eye also. Okay. So, for example, right now if you are looking into that mobile, you cannot see the back side of that mobile there. Okay. And the object which is covered by that mobile, if any object is there backside that mobile, that is also not visible 100%. Okay. Some portion of that object is what? Hidden there. So, that is why the title is called as hidden surface removal. If any such hidden surfaces are there, that should be get removed, or visible surface detection, means the surfaces or the part or portion of the image which is visible, that should be made displayed. Okay. So, that is the title over here, a very important topic in creation of the images in computer graphics is concerned here. Okay. And under this particular title is concerned. Okay. So, in this particular concept we are going to discuss the different types of algorithms and procedures. Okay. So, what are the different methods are there with which we are able to perform this hidden surface removal or visible surface detection. Okay. That we are going to study here. So, as per the syllabus is concerned, so we are going to study two different methods over here. So, the first method is actually the first one is back face removal. Today we are going to discuss that back face removal, and that is the one method, and another method is very popularly it is known as the Z buffer algorithm or depth buffer algorithm. So, these are the two concepts that we are going to study under this particular topic, and these two are the methods with which we can able to remove the hidden surface, or we can detect the surface which are visible. Okay. So, before starting to discuss about those two methods here, okay, so there are so many different approaches are there in hidden surface removal, or you can call them as a algorithms also. Okay. So, all those methods or algorithms have been classified into different approaches, okay, under hidden surface removal is concerned. So, there are two different approaches are there, and your algorithms will lie in any one of these approach. The first approach is object space approach, okay, and the second approach that we will discuss later, that is image space approach. So, once again I am repeating, in hidden surface removal, okay, there are so many algorithms are available, and all these algorithms are going to work based on two different approaches. The first approach is object space method, and another approach is image space method, that we will discuss later. Okay. So, let us start with the object space approach. Okay. Normally, in object space method or this approach, as the name itself indicates here, in any 3D image is concerned. Okay. So, there are n number of objects will be there, and here out of those n number of objects, every time I am going to take one object and that object will be compared with the other object, means whether this object is going to overlap with the another object, whether that object is overlapping with what, the another object. So, like that, just we will go on checking every time we will be taking a pair of objects and we will be comparing every time. Okay. See, for example, say if there are k number of objects are there. Okay. If there are k number of objects are there, then and every time I will take one object and I will be comparing with k minus 1 number of objects. Okay. So, here k into k minus 1, hence the complexity will be big O of what, k square, that is the complexity of this particular approach is concerned. Okay. So, this is what the object space method. To better understand, for example, just we have taken one simple example over here. Assume that there are two objects, means there are two polygons are there, A and B, and what about the different possibilities with respect to those two polygons A and B here. The very first possibility is A might be completely overlapping with what, B. Okay. At that time, if A is completely overlapping with B, then automatically A should be what, displayed, and B will be always hidden, that should be get removed. Another case, what may happen, B might be completely overlapping with what, A, then I am going to display the B and A should be get removed. Why? Because it is what, hidden. Okay. Similarly, both third possibility, both A and B are completely visible. At that time, normally what we will do, we will display both A and B. This is another possibility. Then last possibility is there. What is that? A and B are partially overlapping with each other. At that time, what happens? We cannot discard any one there. We have to make a proper computation over there. That is, we have to calculate the visible part of each polygon. Okay. Now, just have a look at this example figure here. Okay. So, in this figure, you can observe there are two polygons A and B. So, in this particular example is concerned, see there, some portion of A is overlapped with B. So, that portion which is overlapping with B, that should be get removed. This portion of the A should not be visible, but B should be fully made displayed, means visible. At the same time, A is overlapping with B, means some portion of B is not visible just because of what, this A. See, look at here. So, that we need to calculate and computation should be done. Okay. Similarly, if both objects are not at all overlapping, then I have to completely that you have to display completely A also and what, B also. Okay. So, in last case, what is happening, B is completely overlapping with what, A. So, A is completely hidden, it is backside. So, A should be get removed, hidden surface removal. Okay. Only B is what, visible, that we have to display here. So, like this, normally in object space method, what happens, every time I will take one object and I will go on comparing with what, n minus 1 objects. So, this method is called as what, object space approach. Okay. This is one approach with which some of the algorithms or some of the procedures will work out. Then we will go for the second approach. The second approach is image space approach. Okay. So, actually this image space approach is going to work based on the ray casting model here, ray casting model. So, just try to understand the difference between this image space and object space. In object space, we have to compare the object by object, but in image space what happens, we are going to compare pixel by pixel, not object by object. That is the main difference here. We always in image space method, we will be processing the polygon or the surface of the particular object image by pixel by pixel. That is the reason that it is going to work out with ray casting model. So, what is this ray casting model here? Just have a look at this particular diagram. So, here what is happening? Okay. So, in this diagram, imagine that this is the center of projection COP, or imagine that here is a viewer. Okay. So, here is a viewer or camera is there here at this particular position, and here are the objects are there. Let it be 3 objects A, B, C. There are 3 objects are there in the space. Now, if this is the order of this object's position, then what image that I am going to get it on this place where my image will be get displayed over here. Just have a look at here. You can observe in this particular output, A is fully made visible and some portion of the B is not visible. Why? Because A is overlapping, and C, some portion of C is also not visible because C is overlapped by B, and C is overlapped by also what? A. Just have a look at here. So, this is what happening. Now, how it will be get determined? Okay. So, here what happens in ray casting method? Okay. Imagine that from the center of projection, okay, center of projection, we are going to pass one ray here, okay, and that ray will pass, okay, the 1 pixel point of that particular object, then it will pass through the next object of that same position in that pixel point, and then it will pass through what? The next object. Okay. Now, this ray is going to intersect with how many objects here? 3 objects. Out of 3 objects, now what will be happening? By apparently we can say that this in this ray casting model, my ray which is emerging from the center of projection is passing across one particular pixel point position, is going to hit the surface A first, okay, then B, then C. Okay. When I look into the depth information of these things, this is the distance from this viewing display to the A, or that is just have a look at these distances. See, this is the distance, see here, this is distance from here to C to here, it is up to A, up to B, and up to C here. Okay. So, from this particular distance calculation, we came to know that what A is at the front side, okay, and B is back side, and also what? C is back side. It means that B is the pixel point at that position is hidden for what? B and what? C. Then we need to conclude that only A should be get displayed. So, like this here, the pixel point of one object, the depth information of the pixel point of one object will be compared with the depth information of the next object, and that will be compared with what? In the next object. So, like that we are going to take. So, for example, say in this case, if any object consists of m cross n number of pixels, okay, okay, and we are having k number of what? Such objects, then m into n into k, that is nothing but what? Big O of k, the time complexity will be what? Big O of k. So, this is what the image space approach, and where it will work based on the ray casting model, where the objects are going to get compared with the depth information of the individual pixel point compared with the rest of the objects. So, this is what the image space method, and I hope that we have understood the difference between object space and image space. Okay. So, now we will go for the first method, that is back face removal. It is a very simple procedure or a method or the technique that we are going to use. The name itself indicates that back face removal, the face which is back side of any object, that should be get removed from the display of the image. Okay. So, here this particular method is used for what? To eliminating all the back facings of what? The polygon is concerned, and this removing of that back facing is also called as what? Culling. Just have a look at this particular word. This is called what? Culling a back facing polygon, and it can be derived from the following figure. Just have a look at this particular figure here. Okay. How I will come to know that whether the face of this polygon is back side or front. Okay. So, the logic that I am going to use here is very simple. So, here what I will do, just see here, we will see the front of the polygon. If the normal, okay, just have a look, if the normal which comes out of the front face is pointed towards the viewer. Okay, see this particular point. So, here for example, say imagine, okay. So, here this is an object, okay, this is a, let it be polygon, okay. Now, here is a viewer. So, here what I will do, I will draw one normal to this particular polygon. I will draw one normal. You know what is normal? Normal will be always perpendicular to the that surface. It will make a 90 degree. Okay. When I will draw the normal, imagine that this is the direction of the normal, and here is a viewer, and I will draw one viewing direction. So, this is my viewing direction. Is it clear? So, my normal, whatever that I am going to draw, you should also be pointing towards what? The viewer only, the viewer only. So, it means that how I can make it mathematically, I can relate this one here, just have a look at there. So, in this case only, okay. So, here is a viewer, this is the viewing direction, and here it is the normal, okay, that we have drawn. Now, it will make one theta angle between that viewing direction and this normal, and that theta should be what we say, that theta should lie in between minus 90 and 90. Okay, that theta should lie in between what? Minus 90 and 90. Then we can say that, okay, that particular face is what? Front side, means visible to the viewer, okay, and also the direction of that normal is towards, pointing towards the viewer. If it is not happening, see for example, say in this particular case, if you take in the another diagram here, what is happening here? Okay, so here is a camera or viewer. So, this is the viewing direction, this is the viewing direction, and now see there, is a tripod is there, and this gray color face I want to see, I want to check whether it is a back face or a front face. For this face I have drawn one normal here, you can observe here, I have drawn one normal. Okay. Now, that normal direction is gone opposite to the viewer or this camera, okay, and whenever you make this angle, okay, so that will fail into this to make this condition holds good, okay. So, it will not, it is not going to hold good, then automatically I can conclude that what happens, this particular face is what? Back side, okay. Why? Because the normal is the normal that I have drawn, it is going away from what? In opposite direction of the viewer, or in mathematical way I can say that this particular condition, that is theta, should lie in between minus 90 to 90, it will not happen, or in general in terms of trigonometry, cos theta is greater than or equal to 0. Why? Because cos 90. Okay. So, or in general another way, in terms of dot product I can say that if n is what? The normal drawn to the polygon surface, and v is the direction of viewer, then the dot product n dot v, okay, should be greater than or equal to 0. This is the condition that holds good. Okay. Then I can say that the face is whether it is the front side or back side, then automatically I can remove the back face. Is it clear? So, this is what the concept of what back face removal. Just I will repeat the logic here, this is very simple. So, here it is, for example, say here I want to check whether this face is front or back here. First I will draw the normal here, okay, one normal, and then this is the viewing direction, then the angle which is made between this viewing direction and normal should lie in between what? This condition should hold good. Then I can say that this face is what? Front side. If I want to see the back side of this one, and when I will draw the normal, see there, the normal will be like this, it is moving away from what? The direction of the viewer, then automatically the angle is what? It will not hold good, okay, more than that, then automatically the face is what? Back side. Is it clear? So, this is one simple technique which we are going to make use for removing the hidden surface, or we can say that is a back face removal. Okay. So, in the next class we will discuss about the another algorithm, that is called very popular algorithm, Z buffer or depth buffer algorithm. Okay. Thank you.